This conference will now be recorded.
Yeah. So what is meant by thread, ma? Yeah, even Shushma came. Yeah, what is meant by thread? Hello. Lightweight process. Yeah. I think yesterday I have mentioned, right, that C, C++, those are process-based programming languages. When it comes to Java, Python, all these things are thread-based programming languages, where instead of going with a big process, what we can do, we can split a big process into certain, what you say, partitions. Each and every partition is called as thread, where that particular partition will help us in performing individual operations. Got my point, right? Yes or no, ma? Yeah. Now, the main important question which arises over here is, are you guys able to see my screen? Now, the main important question which arises over here is, what is the difference between thread and a function? Can you tell me, ma, what is the difference between thread and a function? Hello? Yes or no? No idea. Okay. Sushma, any idea, ma? Okay. I think, Sushma, yeah. See, ma, first, let's assume we three are working for same company. Let's assume in that way. We three are working for same company. Now, suddenly, I thought of to take some printout. Got my point, right? I thought of to take some printouts. Where at the same time, even Meenakshi also, even she is thinking to take printout. Only one printer is there in that particular area. I mean, in that location where our cabin is there, only one printer is there. So we have to adjust. Both of us has to adjust for taking the printout. Let's say if Meenakshi is expecting some 1,000 sheets of printout to be taken, I'm expecting somewhere 10 sheets of printouts to be taken. Both of us has what do you say? They have raised a request for printout at the same time. Okay. Now, what happens? We will come to printer room. At that time, if you behave like a function, got my point, right? If you behave like a function, what we will do? First, we will whomever comes first, at least 1 second delay, more or less will be there, right, Nama? So with that delay, whomever comes first, that particular person will go for taking the printout. Got my point, right? Will go for taking the printout. Now, until that particular person completes his printout, the second person has to wait in the queue. Either it is 1,000 pages. Let's say if Meenakshi has come first, she will take her 1,000 pages into printout. Got my point, no? She has to take 1,000 pages printout. Until she completes 1,000 pages printout, I have to wait in the queue. That is what function, what do you say, function technique. Got my point, Nama? Is that clear? Yes. Suppose if the same situation comes, for a thread, let's say me and Meenakshi, if both behave like a thread, what we will come to a conclusion first. Okay, Meenakshi, let you take one page printout, even I'll take one page printout. Like this, with some understanding, we will be sharing that particular resource. What is the resource? Printer is the resource over here. We will be sharing the resource and we will take the printout over here. Got my point, Nama? Yes. So when it comes to threads, it will be having some mutual understanding. Remember this point. Threads will be having mutual understanding. So with that mutual understanding, we will be sharing the resource. When it comes to functions, mutual understanding will not be there, where they will behave like selfish. Whomever comes first, they will finish that particular operation, then only they will release the resource. Until then, they have to perform the operations repeatedly. Is that clear? They have to, as well as they will be performing operations repeatedly. Any doubts so far now? Okay. Now, to explain about this particular threading concepts, we have got totally two different algorithms over here. One is producer consumer problem. Okay. First one is producer consumer problem, and the second one is dining philosopher's problem. What is this producer consumer problem? What is this dining philosopher's problem is what we are going to see right now. Now, let's assume we have got a, what is this, clay pot. We will consider it as clay pot. Okay, now we'll consider a clay pot. And there are two people available. One person name is producer and other person name is consumer. Now, what is this particular person's work? Producer's work is, he knows only two things, ma'am. Either producing the food, otherwise sleeping. Only two things he knows. Is that clear? He knows only two things. One is producing the food, otherwise sleeping. When it comes to consumer, even he knows only two things. One is consuming the food, otherwise sleeping. Clear, right? Yes or no? Yeah. Now, when it comes to this clay pot, this is needed for both of these people. For producer to produce the food and to store the food into the container, we will take the help of this particular clay pot. For consumer to consume the food, he need one container, that is this clay pot. So for both of them, this particular clay pot is needed some or the other way. And one condition with respect to this clay pot is, if both the people comes into the picture, that means this clay pot has one restriction, ma'am. Only one person has to insert his hand at a time. Remember this point. Only one person has to insert his hand at a time. If both the people, if they try to insert the hand at the same time, this pot will break. That is what called as deadlock situation. Is that clear? Okay. Now, to avoid the deadlock situation, these two people has to utilize this particular resource properly. How they will utilize the resource is what our producer consumer problem is all about. Now, if they both the people, I mean producer and consumer, if both of them behaves like a function, what will happen? Both the people, they will be inserting the hands at the same time. Clear, right? Both the people will be inserting the hands at the same time. When both of them inserts the hand at the same time, this pot will break. Clear, right? That is why you should not utilize function concept over here. So what we will do, we will make them to work like a threads. Whenever you make them to work like a thread, when he is inserting the hand, he will be waiting. That's what I said, right? One person, he knows, they know only two things. Producer knows only producing the food, otherwise sleeping. Consumer knows only consuming the food, otherwise sleeping. So when he is producing the food, he will be sleeping. When he is consuming the food, he will be sleeping. Like this, with some mutual exclusive understanding, they both will be sharing that particular resource. Is that clear? Any doubts so far now? Okay. In this way, deadlock situation will not happen with respect to our producer consumer problem. Now, next thing. If you have only two threads, one resource, at that time, producer consumer problem is good for explanation. When it comes to multiple threads are there, then which is the algorithm we have that we have to see. Have you heard about dining philosopher's problem? Huh? Okay. Dining philosopher's problem we are going to see right now. Okay. Okay. See. Here, this problem, actually, this is a problem which occurred at dining table. So the name dining philosopher's problem they have assigned to this. And this is a problem which has occurred between philosophers. Who are philosophers, ma'am? Who are philosophers, ma'am? Who preach? Okay. Our Babas, whomever Babas are there right now, those people are considered as philosophers. Correct, Nama? Huh. Where these people, what they know only two things. One is either giving the speeches, sorry, here dining table, right? Here they won't be giving speeches. They know only two things. One is reading to gain the knowledge. Another one is eating. At dining table, they will be reading some books and gaining knowledge to give speeches. Other one is it is just like eating. Only two things they know at that particular point of time. Now, and that too, these philosophers are not from India, they are from China. Why I am picking these people from China in the sense, Indian people, if you say have food in the sense, we will look for spoon. If spoon is not there, we will look for normal, regular hand only we will use and we will have the food. Correct, Nama? Yes. When it comes to Chinese people, how they will have the food? Chopsticks. How many chopsticks they want, ma'am? Huh? Four? No, ma'am. Each person needs two only. Correct, right? Okay. Each person needs two chopsticks to have the food. Here, the problem arises over here is we have got only 6 chopsticks with us. How can you solve this problem? If they behave like a function, listen, if they behave like a function, what they will do, one person now, he will say, I want to eat, so he will take out two chopsticks. Even he will say, I want to eat, he will take out two chopsticks. At the time, even he will take two chopsticks, even he will say, I want to eat. Then what these people will be doing, even those people also will say, even I want to eat, I want to eat. He will be pulling two chopsticks, one from him, one from him. He will be pulling from him, he will be pulling from him. Like this, they will be pulling their neighbor's chopsticks. Correct, Nama? So nobody will eat. That is what deadlock situation. Is that clear? To avoid this deadlock situation, what we have to do, we have to implement the concept of thread. In this thread, what we can do is, three people will be eating, two people will be reading. Three people will be eating, two people will be reading. Three people eating, two people reading. Like this. With some mutual understanding, as it is a threads right now, with some mutual understanding, we will proceed in this way. Is that clear? Yes. This is what your dining philosopher's problem, where in dining philosopher's problem, mutually exclusive operation is happening with respect to more than two threads. When it comes to our producer consumer problem, only two threads we were using. Correct, Nama? Can I have the next one? Okay. So these are the two important algorithms what you have to remember. Now we have to proceed with next concept, that is how many possible ways we can create a thread. Right on? Possible ways to create a thread. There are two possible ways to create a thread. One is by underscore thread. One is by underscore thread. Another one is by threading. Another one is by threading. Is that clear, ma? Yeah. Where underscore thread, we won't be using it regularly, ma. Remember, underscore thread, we won't be using it regularly. Only this particular, what you say, threading concepts, we will be using it regularly. Remember this one. Okay, na? Yes. Now, first, let me show you with respect to underscore thread how that works. Then we will go for threading. Okay, na? Seema. Here we are importing the underscore thread as well as we are importing time module over here. Next, we have got a printing function. You can see here try and accept block is there. Underscore thread dot start new thread. I'm starting a new thread. What I'm starting, I'm calling this printing function as a new thread. Printing function I'm calling as a new thread. What this printing function is doing, it is taking a thread name, delay, how many times it has to perform. So control came here, counter. Counter is 3 times it has to perform. So with the delay of 10 seconds, it will print thread name. You can see it will be like this now. See, this string is expecting 2 parameters. So thread name is, this first parameter will be replaced with thread name. Next, second parameter time is, this second parameter will be replaced with current time. Is that clear now? Then I'm decrementing the counter. Again, I'll go for next time. Like this, with the 10 seconds delay, I'll be performing this operation for the first thread. Is that clear? Both of you? Yes. Next, actually, second thread also we have to start with the name 2 and delay 10 as well as counter 3. But the problem over here is, after the completion of first thread's operation, what it will do, it will go to exception. So second thread will not start up only now. Remember this. Got my point, right? Second thread will not start up only. So this particular technique, at the same time, this technique will not follow any life cycle methods. So this particular technique will not be encouraged in real-time scenarios. Is that clear? Yes or no? Yes. Now let me run this and check it out. After 10 seconds delay, you will get the result. You can check it out. This is the first time, and see, 10 seconds delay gap will be there. After third time, this will go to failure because third time, 3 times only first thread will be done. So it will go to failure after the third thread. Clear, right? Yes or no? Yes. So this is how your underscore thread will be there. As I said, this is not encouraged in the real-time projects. So you can simply skip this particular concept. Directly we can get into another concept. Is that clear now? Next, right on threading. It is a process of, yeah, threading. Threading. Okay, na? It is a process of creating a thread by deriving the features of threading module is called as threading. Is called as threading. Okay, Nama? Next, threading will follow proper life cycle methods for performing operations in our programming. Okay, so If you are following proper life cycle methods, Mama, then only it will be considered as proper thread. Okay, na? What are those life cycle methods and how that will be used is what we are going to see right now. Clear, right? So, proper life cycle methods. First one, write down start. First one is start. It is a method. It is a method which is used for initializing and starting the thread created in the program. Clear, Nama? It creates the thread and starts the thread. Next, start method will look for run method once the thread is started. Once the thread is started. Next, write down about run. It is a life cycle method of thread. It is a life cycle method of thread which holds the business logic for performing operations once the thread is started. Once the thread is started. Okay, Nama? Next, write down sleep. Sleep. Sleep is a function. Sleep is a function which is meant for suspending the thread for a number of seconds during its operations. Okay, na? During its operations. Clear, Nama? Okay. So these are the major life cycle methods now. Start, run, sleep. Now, first, let me See here, we are importing threading, we are importing time module. We have got a class which is deriving the features of threading.thread, where this particular class right now it got converted into thread concept. Clear, Nama? It got converted into a thread. What this particular thread will be doing, you can see we are overriding as per lifecycle methods. We have to follow these lifecycle methods now. Now, here run function is there. What this is doing, first I will get the value 0. We are printing 0 as well as current time, and it is going to sleep for 1 second. When this is sleeping for 1 second, control will not wait there only. See, second thread, you can see, even this is also having same logic. We have run function, 0 will be stored into j will be printed, that is 0, current time, as well as we are going to make this thread to sleep for 1 second. You can see we are creating an object for first thread, we are starting up first thread. We are creating an object for second thread, we are starting up second thread also. So if you observe, when first thread is started, this performs the operation. When this is sleeping, second thread will get started. So 0, 0, 1, 1, 2, 2, 3, 3, like this. With the proper sharing, this gets executed. Check it out. I0 with 1 second delay, you will get the result. Clear, Nama? Sushma. In this way, your thread need to be following life cycle methods, and it will work like this only, ma. Okay. Now, first question over here is, how many threads are there in this program? How many threads are there, ma? Meenakshi? 2. No, it is not 2 more, it is 3. This is one thread, this is second thread, and wherever objects are getting created, that space by default that is called as main function, that is called main thread. Is that clear? So totally 3 threads are running in this program. Wherever you are creating objects, where you are starting your program, that particular area is called as main thread. Okay, na? Okay. So this is one thread, second, third. If you want the proof, you can see threading.active count. How many threads are there? If I run this, it will give you the count also. See, count it is giving 3. Clear, Nama? Okay. If you want still more in detail, which are the threads running currently, you can take the help of this one. Threading.enumerate. This enumerate will give you the details about the threads which are running. If I run this, see, it gives the details like first list of the threads running. This is one thread. This is second thread, thread hyphen 1. Next, this is third thread. Like this, how many threads are running? It will enumerate, will give you list of the threads. If you want a count, you can take the help of active count. If you use enumerate, it will give you the list of the threads running in the program. Is that clear? Okay. Next. By default, names for the threads will be main. For main, it will be main thread, and other threads what user is creating for that thread hyphen 1, thread hyphen 2, something like this, it will be available. Where if you need to give a new name for that. You can see set name you can use. I can assign new names like this. For first thread, I'm giving the name as first, I'm retrieving the name. Second thread, second, and I'm retrieving the name. Check it out. First thread, second thread, names you can assign. You can see here also. Clear, Nama? Yes. So in this way, we can set the names as well as we can get the details about the threads, what is available, everything. Next. Now we are going to see next important concept. That is, if a thread is done with its operation. Got my point, right? Once the operation of a thread is done, why we need that thread to be alive, ma? Got my point, right? Once the operation is completed with respect to a thread, why we want that thread to be alive? For that sake, what we have to do? We have to kill that thread. So we will take the help of this one. See, if f dot is alive, if the thread is alive, f dot join. Join means join is a function which is meant for killing the thread forcefully. This enables garbage collection also. Clear, right? Yes or no? Yeah. First, after completion, see, after our operations are completed, then what we are doing, we are checking whether the thread is alive. If the thread is alive, we are killing the thread over here. Like this, for first thread also we are doing, second thread also we are doing. This is how you have to do it. Next. Now, important interview question. I won't use start, I will use run. What is the result? Got my question, Nama? Actually, life cycle methods are start, run, sleep. But here I am not following that particular life cycle methods. I am going for run instead of start. So what happens? Will this get executed? If so, what will be the output? Is what my question is all about. Thread will not be initialized. Okay, next ma. Shushma? No idea. Okay, fine ma. Let me tell you. See, here what happens is, whenever if you start up a thread using start, it starts like a thread only. Now, if you are using run, here we are calling run, so control will get transferred to run function. This performs the operation. So run and run, if it is going, then it will be considered like a function. It won't be considered like a thread. Remember this point, ma. Usually how we will call our functions? If a display function is there, we will call it as that particular object dot display. Same thing here, that particular class object dot run we are calling. So it works like a function. When function concepts comes into picture, what you say? You will be having this particular. So in this threads will not be used. No ma, it won't. Threads will not be what you say coming into picture. Function domination will comes into picture. So right now it behaves like a function. You can check out the result. I is 0, I is 1. So first one, it will behave like a selfish. Once the first one is completed, then only second one will come into picture. You can see. Clear, Nama? That is what. Very important thing. In interview, they'll ask this one. Instead of start, if I use run, what happens? Most of the people, they'll say it will raise an error or something like that, they'll say. But the actual truth is this one. It won't behave like a thread. It behaves like a function. That's it. Can you next one more? Next. Let's say we have got a thread, but still I want to make that thread to work like a function, not in this particular way, not using this run function, some other way. How to make a thread as synchronized is what the question they will ask. Otherwise, how to convert thread to a function is what the question they'll ask. So what will you answer, ma? Not this example what I have, I made it as run, so because of that it turned as a, what you said, a function. That is not the answer. For that, one more thing is there. That is what I'm going to show you right now. Is that clear, ma? Okay. Write down heading, thread synchronization. Thread synchronization or locking is a technique which makes only one thread only one thread to perform the operations at a time. Okay, Rama? Now, see here, we are importing threading, we are importing time. Now, you can see here we have got a class. We'll come to this class a bit later. Say, here I'm creating a lock. That means it is just like I got one lock. For what purpose I have got a lock, we will see later. You can see thread 1 equal to my thread 1 comma first comma 1. Thread 2 equal to my thread 2 comma second comma 2. And I'm starting my first thread. So whenever you are creating an object, you are calling parameterized constructor. So see, my thread, we are passing three parameters: thread ID, thread name, thread counter. So we are initializing thread ID, thread name, thread counter over here. Is that clear, ma? Yes or no? Hello. Okay. During object creation only, we are supplying all the three values. All the three values are passing to our constructor, and we are initializing thread ID, thread name, and counter. Okay. Next, we are starting up our first thread. Once if you are starting first thread, control will go to your run function. Control will go to run function. What this run function is doing, it is acquiring a lock. It is just like it is a thread, but after entering into the function, it is locking its room, and it is calling internally one resource, that is printing function. It is calling printing function. What this printing function is doing? It is taking the name, counter, as well as delay. It is performing the operation for 3 times. After that, control will come back. It is releasing the lock. Is that clear now? First, we are acquiring the lock. We are performing our operation. What operation? Here I have given some dummy logic. Okay, na? It's your wish. What you want to do, you can do it. How many times you want to do, how much time you need the control to be there in that location. You keep it. After your operation, you will come back and you will release the lock. Is that clear? Sushma. Then second thread also we are starting. Initialized, we are acquiring the lock. Of course, they are threads only, but they are not behaving like threads right now. It is until its operation is completed, it is not giving the chance for others. Got my point, right? Those are good people only. But for that particular time period only, they are behaving like a selfish. They are locking the room, they are performing their own operation. After their operation is done, they are releasing the room. Then whatever the threads, you can see we have created a list. In the list, whatever the threads are there, we have created everything we are appending. First thread we are appending, second thread we are appending. From the list, one by one, we are getting a thread and we are asking to join. Join means it is killed. Clear, Nama? Yes or no? Yeah. Check it out. See, first thread will execute 3 times, then second thread will get executed 3 times. Like this. So even it is a thread, but we are making it, we are following a procedure to make it work like a function. That is what your thread synchronization, otherwise thread locking is all about. Clear, right? Can I proceed with next one? Yes. Okay. This is what your threading concept is all about now. Remember this point. Next. Now, did we finish that random module, ma? Random loggers. Random is not completed? No. Okay. Fine. First, write down about random. Then we'll go for loggers. Random. It is a module. It is a module which is meant for generating random values of its range. Okay, Rama? Generating random values of its range. See, basically, whenever if you want a random values like captchas, OTPs, in these kind of scenarios, we will take the help of this random module. Ma. Is that clear? Okay. Now, here we are import random as rand. That means I am importing this module where I am referring this random module as rand over here. Next, rand dot random. I am generating some random number. And uniform distribution algorithm, Gaussian algorithm, expovariate algorithm, these are all predefined maths algorithms now. As per uniform distribution algorithm, within this range, what is the value? As per Gaussian algorithm, within this range, what is the value? Expovariate algorithm, within this what is formula, what is the written value? If you want to generate, it will generate. Every time it will generate different value, and there is a chance of repeating the values also. Remember, whether it is positive, negative, that cannot be predicted, but it generates repeat random values. Clear, Nama? Can you have the next one? Now, see this one. I created a variable where it is holding the value 1 lakh. I have created one more variable where it is holding the value 10 lakhs. And I'm printing print numbers. This is one string. A value, again comma, B value, again this string I'm printing. Rand.random int. Within 1 lakh and 10 lakh, what random number it prints, we cannot predict. Is that clear, ma? Within the range 1 lakh to 10 lakhs, what values it returns, we cannot predict. That is one thing. Next, see here. Here, rand.random range, starting, stopping, and step. See, this is the starting point. That means within 1 and 12, and incrementation it is 2. So 1, 3, 5, 7, 9, 11. So within this values, which value it returns, we cannot predict. Got my point, Nama? Within the random range, starting, ending, and step incrementation. Within this values, what it returns, we cannot predict. See? Within 1 lakh to 10 lakhs, you got this. Within this one, within this particular range, you got this. Again, if I run, see? Clear? Any doubts so far?
In the first line, why we gave import random as random? If we just give import random?
At the time here, you have to use random.rand range. That is, I have given as a pet name. That is alias.
Okay, but is there any use of that? Generally, like
instead of giving big names, instead of calling big names, instead of calling you as Meenakshi, I am calling you Meenanama.
Okay, I mean just
it's like short name. Easy way to call. That's it.
Okay. Okay.
That's it. Next. Can I go for next one, ma? Yes. Now, this is one more example. As we have seen this one, we are limiting the range from 1 to 1000. Here, see, previously, if you check it out, rand.random, it was generating some random value. There is no limit for that. But if you want to set the limit, see, random.seed, I'm specifying my maximum limit to 10. So within 10, this random number will get generated. Clear, Nama? Within 10, my random number is getting generated. See, here I'm not using as rand, so I have to give full names, random.random.random. In previous examples, I was using rand, so short names only I was using. Any doubts so far? Both of you. Okay. Next, this is one more example. See, here I'm importing random as rand. I have got one string, KKR Technologies. Next, I have got a list over here. Rand dot choice of string. That means within this string, I'm getting one random character. Which character it returns, I cannot predict. First thing. If you want to retrieve a random character within the list, which value it returns cannot be predicted. Clear, Rama? Yes. And if you want a single character, you can go with any one of this. If you want more than one character, you can use this technique. See, rand.sample. From the string, 4 characters I want. Here, from the list, I want 4 characters. Clear? Yes or no? Next. This list, whatever the list is there, that I am shuffling here. Shuffling in the sense with that elements only will be arranged in a different manner and we are printing it over here. You can check it out. See, first we have got one random character n, random value from the list 13, and random characters, that too 4 characters I got. See, on space also I got over here. Next sample, we got 4 values. After shuffling, see, the order of this particular shuffle is changed. Check it out. Clear? This is what your random module is all about. Next, what is loggers? How many types of loggers are there? How to proceed further? In tomorrow's session, we are going to see. Is that clear, ma?
This week, tomorrow and Tuesday, I can't come. We can't come because I have some work. Like Friday only. Wednesday I will come, and Friday this week, and then Saturday, Sunday.
So tomorrow and day after, you are not coming.
No. Wednesday,
Okay,
Friday, Saturday, Sunday. Yeah.
okay, ma. Then we will meet up on Wednesday. Okay, Nama?
Okay.
Shushma?
Okay.